Hi! Today we're going to learn about calculating concentrations after combining solutions in chemistry. And let's say we have a problem like this. 3 liters of a 0.05 molar solution of KCl is mixed with 5 liters of a 0.2 molar solution of Ki. What is the concentration of the K plus ion? So before we start, let's go back to one formula that we know. So one really important formula that we know is volume times molarity equals the number of moles. And we get that because we know that molarity, big M, is equal to moles over volume. And the thing that we have to make sure is when we have this formula, the volume here, the volume of the molarity, and the volume here should have the same unit. So they should both be liters or both be centimeters cubed or something like that. So essentially this problem is just volume times moles over volume is equal to moles. And we can see that because the two volumes will cancel out and we'll just be left with moles are equal to moles. So let's start off by using this formula. For this first solution here, we have 3 liters of a 0.05 molar solution. So the volume is 3 liters, so let's just say 3 liters of a 0.05 molar solution of KCl. So 0.05. And here's another thing that you should know. Whenever there's just big M as the standard for molarity, so instead of having moles over centimeters cubed, whenever you just have M, a capital M, this is just the standard notation for molarity, is equal to moles over the volume in terms of liters. So if it's not over the volume in terms of liters, it won't give you M, it'll give you moles over the volume in terms of whatever unit. But in this case, we know that because it's capital M, it's in terms of liters. And we know that the volume that we have here should also be in terms of liters, which it is. And if it wasn't in terms of liters, we would have to convert it to liters. And now let's move on to the second solution. So let's not multiply it as yet. The second solution has 5 liters, so once again we're in liters, times a 0.2 molar solution with capital M. So liters is our unit for volume. So let's multiply these together. So here we would get 3 times 0.05 is equal to 0.15 moles of KCl. So if we break this up, we know that KCl is basically K positive, or K plus 1, plus, and we're doing the arrow backwards, sort of, plus Cl minus. And so if we have 0.15 moles of KCl, then that means that we have 0.15 moles of K plus the ion, and 0.15 moles of KCl minus the cation. So, and another way to visualize this is molarity isn't or moles isn't a measure of volume. It's just a unit of measurement. So let's have an analogy here. So let's say that you have a pile of, this is the pile of chlorine, and you have the pile of potassium, which is K. So, and let's say these are both a mole. You can see that a mole isn't a measurement of volume because 1 mole of KCl might weigh more than 1 mole of potassium. So, or 1 mole of Cl, or 1 mole of chlorine, might take up more space than 1 mole of potassium. And so that means that when you put these two together, this is a synthesis reaction, when you put them together, you get 1 mole 1 mole, 1 mole. You get 1 mole of KCl. So you just put these 2 moles together, and it doesn't become 2 moles, it just stays as 1 mole. Because you have 1 mole of chlorine and 1 mole of potassium. And so you get 1 mole of potassium chloride, or KCl. So that's how we know that we have 0.15 moles of KCl, which is the same thing as 0.15 moles of the K plus ion. So now let's do that for the other solution. We have 5 liters times 0.2 molarity, which becomes 1 mole. So, and we have 1 mole of potassium iodide, or Ki, which means that we have 1 mole, let's just say 1 mole of K plus again. So now let's do something else. And another thing to keep in mind is, let's say the formula had K2 and then something else in it. So let's say it was K2O. Even though, yes, let's just say it was potassium oxide, or K2O. So the the number of moles of the solution is 0.15. And that is also the number of moles of K2. But that number of moles of just K would be twice the number of moles of K2. So that's just one thing to keep in mind. Or actually it's not like that. Sorry, it's the exact opposite. So 1 mole, or let's say you have 0.15 moles of K2, then the number of moles of just K would be the number of moles of K2 divided by 2. So it's just that simple. And that means that the molarity, which is a concentration, is twice as much. And we'll see how. So, or it's not, it's still half, sorry. So the number of moles is just half. So now let's do something. So we know that molarity, which is what we're trying to find, is the number of moles over volume. So let's add up the moles of K plus, and let's add up the volumes. So in our new solution that we have 8 liters of some aqueous solution. Times some molarity, let's say X, is equal to 1.15 moles of our new solution. So to find X, which we know is the molarity, from the V times N is equal to moles formula. So to find X, we do 1.15 moles divided by 8 liters. And on a calculator, when we do that, I happen to know this, when we do that, we get 0.14375 molarity, which is equal to, and this can also be expressed as 0.14375 moles over liters. So that's just showing you that the capital M is just moles over liters. Today we learned about calculating concentrations of after combining solutions. Thank you for watching this video.